Alright, AP Stats, this is our Chapter 1 little recap video, and hopefully this will go pretty quick. So, the main part to Chapter 1, I really think there's three main parts overall. Chapter 1 is mainly about describing distributions, and in that, it also talks about your standard deviation, which is just part of a distribution, which is the spread. And then we ended with transformations, linear transformations in particular. So we're taking our shape, center, and spread and translating them up or down or stretching them wider or smaller as we go. So I'm going to just kind of breeze through the packet and talk about the most important parts. Now, if you notice, it says chapters 1 through 3. That's in our current book. It's 1 through 3. Our old book was chapter 1. Nobody has bothered to even ask me about that, even though I say we're testing on chapter 1, in a couple days. So let's take a quick perusal through our packet. So the first couple pages I'm not going to bother with. There's the Fathom introduction, and if you want to go back through any of that, you can ask for a pass down to one of the computer labs. Actually, I'm not even sure how that would work, because you can't really get in the computer lab without a teacher. However, I'm not 100% sure. We could check. The library might have them. But for now, we're going to skip that. We got some definitions, and we talked a little bit about the difference between an observational study and an experiment. So, briefly touch on that. The big difference between an experiment and an observational study is in an experiment, you're actually doing something. There's a treatment that you're applying to your experimental units. Your subject has some sort of treatment that's involved in it, whereas in an observational study, you're not actually applying any treatment to. So the big difference between them is there a treatment or not? If there's a treatment, then we're talking about an experiment. If there's not, then we're talking about our observational study. We might use these questions were kind of vague. They're vague on purpose, more to spark discussion than anything else. But again, big difference between experiment and an observational study. Experiment has a treatment, observational study does not. Alright, so which types of graphs should you use? The basic ones for qualitative data, which is also categorical data, are your bar graphs and your pie graphs. And if I'm asking you what type of graph you should use for a certain display, you really have to decide whether you want to do quantitative data or qualitative data. If it's quantitative data, then you're talking about a histogram, a stem and leaf plot, or your dot plot, or your box and whiskers chart, which is not on this page. But any of those would be available for us in quantitative data. So if it's numerals, if it's numbers, if the average makes sense, it's quantitative data. If the average doesn't make sense, it's qualitative. Remember, we talked a little bit about zip codes. You can have different zip codes and their numbers, but averaging two zip codes doesn't make any sense. They're more of a category than anything else. You don't use a bar graph or pie chart for quantitative data because it really doesn't make sense. You can kind of do things like using a histogram and treat them like bars, treat them like categories themselves, and it would make a little bit of sense, but it's still just not the right thing. So what is the distribution? It's kind of a very general question. When you're describing a distribution, you're describing your shape, center, spread. But the distribution is basically all of the options that a data set can take. So our data sets of pennies, when we look at all the pennies put together, that is our distribution. Our distribution has an average, it has a median, it has a mode, it has spread. So it is basically your data set more than anything else. And also it has all the categories of your data set. It talks about min to max. Everything is part of a distribution. Alright, and then we talked a little bit more about categorical, talking about making graphs. And a lot of this chapter is about making a graph and being able to, say what your graph means. Now, one of the big things you want to do when you're making your graphs, and I know you can make the graphs, is don't forget a couple main things. If you're making a stem and leaf plot, you have to include a key. And your key really should be in, some units. So these are height. I don't have our data in here, but let's say there's the 50s, we're in the 50s, we're in the 60s, and the 70s. And, I don't know, 58. So 5/8 stands for a 58 inches. Now, this is almost enough just because you're putting the inches on there. But you could also put there, it's the height of a female in our set. But you really have to have a key of some sort. And not just a number, but you should at least have units, if nothing else. What's the purpose of the back-to-back 7-leaf plot? Well, anytime you have two graphs next to each other, the main purpose is always going to be able to compare them. Alright, as far as making histograms, the number one thing I would tell you to do on any histogram or making any in the future, I want you to be able to do this by hand, but mainly it's using your calculator. So I'm going to go back through the calculator steps really quick. So let's bust up a calculator and let's make sure it all fits in my screen here. And so the main thing, if you haven't seen this in a little while, you're going to go to your stat, you're going to go edit, and then we're going to put a bunch of data in list 1. And it looks like these are just numbers 1 through 9. So, which is fine. However, it's not really all that interesting as far as a histogram. So I'm just going to put a bunch of kind of random numbers going through here. But I'm trying to make sure I have a couple of these. So, pseudo-randomly selecting some numbers just so I have some numbers in there. Alright, to create your histogram on your calculator, type all your numbers in your list. Be very careful that you're not mistyping them. I mean, I kind of made these up at random, so I can't really be wrong. Hit second, y equals. Make sure your stat plot is turned on. Make sure you have the histogram selected. And then, I've got this L2 business on here, and it's from something else that I did. You want to make sure that that's either blank or not Y, but get the alpha out of here, 1. So that'll work. You don't want to have your frequency be anything other than 1. That means everything in L1 just gets one of them. If you wanted to say that there's like 5 1s and 3 7s, you could put those frequencies in list 2. Like create your histogram in your list 1 and then say what the frequencies are in list 2. That's a thing, but we're not going to bother with that. And so we're going to, of course, let's give it a minute. Garbage, quit, zoom, none, and we have our histogram. Now, if you got other lines going on here, that's because in your y equals, you've got other stuff going on. So I'm going to go to y equals, maybe, and I'm going to clear this out. And then the other thing I want to do is look at your window. Sometimes it makes a lot of sense, and sometimes it's just stupid. So I want to start at 0, and I want to go to 10. That sounds good. And my scale is 1.8. No. Let's try 2 and see how that works for us. So you got to kind of mess with your window. And then once you have it, you hit trace, and then just look at the numbers. So if you had to do this chart, you can now replace your limits. So it's 0 to 2, and there's only one of them. And then you arrow to the right, 2 to 4, and there's 1, 4 to 6, and there's 4, 6 to 8, and there's 4, and 10 to 12, and there's, 0, sorry. 8 to 10, and there's also 4. So that also brings up another point. On the quiz, a lot of people put like 0 to 1, and then 2 to 3, when you meant the same thing we have here. So you really want to mimic what you get in your calculator, 0 to 2, because you don't want to go 0 to 1, even though the 2 is not counted. Because what if 1.5 is a number that's available? If it's discrete and it can only be integers, I understand 0 to 1, that is one category, and you're including 1. But even though your data might only have whole numbers, then you might have decimals that could fall in between there, and you're just waiting for the next one. And then you wouldn't have anywhere to put it. So you want to, when you're naming your class limits, go 0 to 2, and then 2 to 4, 4 to 6, 6 to 8, 8 to 10. Do not have the upper limit not match with the lower limit. And again, the convention's on your calculator here. It says the max is less than 2. So 0 to 2, but 2 doesn't fit in the first category, it fits in the second. So that's how you create your histogram on the calculator. Alright, so I'm going to talk about histograms. But when you're describing a distribution, you want to make sure that you mention your shape, center, and spread. And if you are, let's go down here so we have a couple graphs to look at. So, in these graphs, if I'm going to describe this, not just this shape, center, spread, this is skewed to the right. The center, now it depends on which one you're looking at. If it's skewed right, that means the mean is higher than the median. And the mode may or may not be at this number. You got to realize that the mode, while it usually is at the peak, this could be a range of numbers. This could be numbers from 1 to 10. And there could be, 10 1s, 10 2s, 10 3s, 10 4s. And so this seems really high, whereas these are 10 to 20, and all of them are 25, whereas the mode might still be at 25. But generally it's going to mean, median, and mode. So the mean is much more likely to be above the median. The mode, while this is the convention, it still could technically be to the right of the median. It could happen. The mean, if you said you're skewed right, that means your mean gets pulled to the right of the median. Second one would be symmetric. Oh, sorry, two other things. So shape, center, spread. So your shape is skewed right, your center, you have to pick your mean or median. But you cannot just say the center is 22. You have to say the average is 22, or the mean is 22, or the median is 22. You can't just say center, because there's more than one center that could be what you're talking about. So you have to explain what you're talking about. And then your spread. By the end of this chapter, when you're talking about spread, I'd rather you talk about your IQR or your standard deviation. So either one of these are really good measures of spread. The range is not too terrible. Your top minus your bottom, that's okay. But we're really going to talk more about these two as we go forward. Okay? And then the last thing to talk about with shape, center, spread is it has to be in context. Now, I have no context for this particular problem, so I would say the data is skewed to the right. Just don't say the data. When you have one of these problems on the AP exam or on your test, it's not going to be just data. It's going to be about your height. It's going to be about your shoe size. It's going to be about like grades. You have to mention shape, center, and spread in context. Okay? Now, other things to note. So shape, center, spread, but other goofiness. So other goofiness might be that it's bimodal. A lot of people want to talk about it being unimodal, but that's not all that exciting. So you can say that. However, skewed to the right kind of means you're going to have one mode over here on the left. Saying it's symmetric means you're going to have one mode in the middle. This one right here, I don't know if I would say it's symmetric, but it's sure not, possibly skewed right. I'd have to figure out what the median is and the mean, but it's really hard to tell if that's skewed right or left. I mean, right more than left, but it still says it's more symmetric than anything. But the big thing to talk about in this case was that it's bimodal. And each mode is basically symmetric about its mode. And then the last one that we talked about very briefly was uniform. They all have about the same distribution, then it's uniform.